All right, the last thing that we didn't get to in here, examples 11 and 12, are actually something that we have done before, so they won't take us very long to remind on how that works. Here they are. But they ask us to use a calculator to solve each equation. It wants us to be correct to 4 decimals, so pay attention to that. And we're on the interval from 0 to 2 pi, so my directions are actually right on this one. So on this one, we're going to have a calculator, and the reason is because we don't have a sine theta value that we know on the unit circle that's equal to negative 0.2. So what we do is we actually do the inverse sign. So you have a button called inverse sign in your calculator. This is also called an arc sign. That's another phrase for it. And the problem when we do this is it's going to give us an angle that's not actually between 0 and 2 pi, and that's okay. Correct to 2 decimal places, it's 0.2014. And if you remember, inside of our unit circle, our sine values, in order to be negative, like it says it's supposed to be right here, would actually be inside of quadrants 4 or 3. And arc functions actually focus us with sine in quadrants 1 and 2. I'm sorry, 1 and 4. So the angle that it's giving us is down here. And that's okay. It's negative 0.2014. But what I want is I want to go the other direction, right? I want to go around like this to get to here. So the way that I would do that is that I would take this and I would add 2 pi to it, right? So if I add 2 pi to this, I'm going to get 6.0818. So this is one of my answers on the interval. There is another one that doesn't come straight out of the calculator, but it comes from us actually having to sort of think about how the circle works. So the other sine value that's going to give us a negative 0.2 would be over here, right? It's the same height, right? These are measuring at the same height. That's why this is working. And it's the same 2.014, it's just that it comes at it from this angle, right? So this is a positive 2.014. But again, I want to go all the way around from the beginning to here, right? So I actually have to take my pi, that gets me part of the way, plus a 0.2014 to get me there. And if I do that, I will get a 3.3430. So we're working with our unit circle, but we're working with it alongside the calculator. Let's try one more. This one wants cotangent of theta equals to 2. And our calculator doesn't have an inverse cotangent button. So what that means is that I need to turn this into tangent. So if I write this as 1 over tangent of theta is equal to 2, that's fine. I'm going to write this as 2 over 1. But I'm actually able to flip these both upside down so that the tangent is not on bottom. So I will change this to say tangent of theta is equal to 1 over 2. Now, if this said sine theta or cosine theta equals 1 over 2, that'd be on our unit circle, but tangent of theta equals to 1 over 2 is not. So we'll do our inverse tangent, 1/2, like this. And again, this tangent is positive, so we want to make sure we're in the right quadrants. This should put us in quadrants 1 and 3, right? Tangent is positive in 1 and 3. So our calculator, if we put this in here, is going to give us an angle measure. It's 0.4636. So it's telling us right over here that this is at 0.4636. And the other one would actually be exactly in the same, along the same line essentially, but in quadrant 3. So it'd be all the way over here. So that 0.4636 is actually right here. And then we'd have to add a pi to it to get the part that here is here at the top. Let me put that in white actually. So this piece right here is pi. So if we add pi to that value, so that's one of our answers, we will get 3.6052, and that would be our second answer.